solution. Solution is made by mixing solute in a solvent. In your daily life, if sugar is dissolved in water, final solution is a liquid solution where water is a solvent and sugar is a solute. Similarly, just see, this water is a solvent and this is salt, which is known as a solute. So when this salt is added to water, we get a salt solution. So solute particles get dissolved in solvent. So what is this solute or solvent? How we define solute and solvent? The medium of this solution that allows one or more components to dissolve in it to form solution is known as solvent, whereas the substance that dissolve in the solvent is a solute, like salt is a solute. And solution of two components is known as a binary. Similarly, three components, it is known as ternary, and four component, that is known as quaternary. Another example, like saline water, which is also a solution, where salt crystals are solute here, which is dissolved in water, that is a solvent. And some few more examples are given on page number 37. Just see, that is liquid with another liquid, that is water and alcohol. Solid with liquid, that is sugar solution or salt solution. A liquid with a gas, that is soda water. A solid with another solid, that is alloys. What are these alloys? Alloys is a homogeneous mixture of two or more metals and non-metal mixing together. And this homogeneous solution, solid, is mixed with another solid. It becomes a solid solution. Like to make jewelry, copper or silver is added to gold. And similarly brass, where 70% copper that act as a solvent and 30% zinc is added as a solute to make a solution, homogeneous solution, where both solid and solids are mixed together and we get a brass. Now, what this true solution is? A true solution is a solution in which size of solute particle is about 10 raised to power minus 10 meters. See how much small the size of the solute particle is. In this true solution, the solute particles and the solvent molecules cannot be distinguished under microscope. That is, the size of solute particle is so small that it is completely get dissolved. It cannot be distinguished. So what are the characteristics of the true solution? Now see, look at the page number 38. The true solution is a homogeneous mixture and the particle size is very small and it is clear and transparent. It does not scatter light and its component cannot be separated by filtration, and the solute particle in a solution do not settle down. Now, water is the most common solvent. It is also known as a universal solvent, and solution is prepared by dissolving any substance in water, then it is known as an aqueous solution. But it is not only solvent. Some more solvents are there, like alcohol, petrol, ether, benzene, carbon disulfide, liquid ammonia. These are the examples other than water. These are also solvent. And some are non-aqueous liquids, solvent in common use. The solutions made in these liquids are known as non-aqueous solution. When the solvent is alcohol, the solution is called tincture. And tincture of iodine, which is applied as a medicine, is a solution of iodine in alcohol. It is act as a cleaning agent also. Similarly, we are having dilute solution and concentrated solution. It is a dilute solution in which amount of solute is rather less compared to the mass of the solvent, then it is a dilute solution. Similarly, when solution in which amount of solute is more as compared to the mass of the solvent, then it is a concentrated solution. Now, what is saturated and unsaturated solution? A solution that cannot be dissolved any more of the solute at a given temperature is called as saturated. And unsaturated, a solution in which more of the solute can be dissolved in a given temperature, that is unsaturated. Like if I take a water, in this I can dissolve more and more salt in it. I have taken water and more solute can be dissolved in it. So like this, in which more and more solute can be dissolved and in which no more solute cannot be dissolved. So like this we can distinguish saturated and unsaturated solutions. Similarly, a supersaturated solution at a particular temperature, it contains more solute than it becomes its saturated solution. And this supersaturated solution, it is metastable, and slight disturbance like shaking, stirring, etc. make additional amount of solute to participate, thereby resulting in formation of saturated solution again. So we can distinguish saturated solution, unsaturated solution and supersaturated solution. So for the example, just look at the book, page number 38. There are some experiments also given how these supersaturated, saturated and unsaturated solutions are prepared. So you just go through the definitions. Now page number 39. Here we are going to discuss about the concentration of solution. The amount of solute dissolved in a given quantity of that solution is known as the concentration of the solution. And the concentration of the solution can be expressed in many ways. First, that is mass percent. Second is volume percent. The mass percent, the formula is mass of the solute by mass of solution, and solution is solute plus solvent into 100%. Example, 10 gram of NaCl divided by solution of salt and water, that is 10 gram of NaCl plus 90 gram of water into 100%. We can express the mass percentage of the solute. So here 10 upon 90 plus 10, it becomes into multiply by 100, it becomes 10% of solute. Similarly, volume percent. Volume of a solute divided by volume of solute plus volume of solvent into 100%. We say, like example, 30 ml of alcohol, it dissolves in 70 ml of water. So solution is 30 ml of alcohol plus 70 ml of water into 100. We get volume percentage. So it comes like 30%. So some more examples are given on page number 39. Just go through these numericals and do these numericals in your notebook. If any doubt, just ask. So what this solubility is? The amount of solute that dissolves in 100 gram of solvent to form saturated solution at a particular temperature is called solubility. Once again, pay attention. Amount of solute, we are taking solute, that, but whatever amount of solute is, but the amount of solvent we have taken here is 100 gram only. So there is a fixed amount of solvent, that is 100 gram, and the solute, the amount of solute, how much amount of solute in 100 gram of solvent can be dissolved to form saturated solution. And remember, there is no change in temperature, there is a particular fixed temperature is there, and that is known as a solubility. So we have different types of substances like insoluble substances, sparingly soluble substances or soluble substances. So what these insoluble substances are? A substance that has negligible solubility like silver chloride. Sparingly means a substance that has more than negligible but less than high solubility. Example, calcium chloride. And what are soluble substances? A substance having high solubility like sodium chloride, a very common example we use in our daily life, that is table salt. Now, what are the factors affecting the solubility? The rate of solubility of a solid in liquid depends upon size of the solute particle, stirring, like continue, you stir the solution solute in a solvent, and the temperature. So these are the three important factors on which solubility depends. So during the process of dissolution, the particles of the solute merely occupy the space between the particles of the solvent. You know the solvent, if I draw the structure of the water, that is water is H2O. So there is a space between the particles, that is hydrogen and oxygen atoms. So these solute particles merely occupy the space between the particles of the solvent without undergoing any chemical change. And you might have seen there is a variation in the solubility of a given substance with the temperature, and different substances at different temperatures show different solubility. So let us discuss about what this is shown by a solubility curve. Let us see on page number 40. So there is one figure shown, the solubility curves for different salts. See, temperature is mentioned here in degrees Celsius, and solubility is shown on y-axis, temperature on x-axis. So different salts are shown here and the different curves. Just see it very carefully. So all these salts are mentioned here: calcium sulfate, potassium chloride, potassium bromide. So many salts are mentioned here, figure 3.7. So what this solubility curve is? The solubility curve is a line graph. As I have shown, this is a line graph that plots change in solubility of a solute in a solvent against changing of temperature. Means when there is a change in temperature, how the solubility of a salt changes. So this is shown by this solubility curves. So it is a line graph that plots change in solubility of solute in a solvent against changing temperature. Now consider increase in solubility with rise in temperature, and some substances increases its solubility with a considerable rise in temperature, some little increase in solubility with the increase in temperature. So there is a decrease in solubility sometime with a rise in temperature. So let us discuss the examples. On the same page you can see, but I have written here in the notes. You just observe it, see it very carefully. So there are substances which show considerable increase in solubility with rise in temperature. Example: sodium nitrate, potassium bromide. Now see in the graph also, sodium nitrate, as I mentioned here, sodium nitrate, potassium nitrate. See, this is sodium nitrate. This shows considerable increase in the solubility. And see the potassium nitrate, increase in the solubility with the rise in temperature. And some salts show little increase in solubility with increase in temperature, like sodium chloride. Now look at the graph. A little increase in solubility, that is, see, sodium chloride show very little increase in solubility. And there is some substances, there is a decrease in their solubility with a rise in temperature. That is, after attaining a certain temperature, solubility decreases. So examples are hydrated calcium sulfate. See the formula of hydrated calcium sulfate. Water molecules are shown here. And other is slake lime. So you have to learn it. These are very important examples. You have to learn. The substances show considerable increase in solubility, little increase in solubility with the rise in temperature, or decrease in solubility with the rise in temperature. These are very important questions. So look at the graph which show decrease in solubility, as I have said, slake lime and the calcium hydroxide. So here this curve line is shown for the calcium sulfate is shown here. This is a curve shown for the hydrated salts in which the solubility decreases with the rise in temperature. So this line represented the hydrated calcium sulfate. So I think this graph is clear to you. So once again you look at it and learn it. Now there are some salts which show anomalous solubility. So look at this graph. Anomalous solubility is shown. But before that, just listen. What this anomalous solubility? There are some salts which show solubilities with different. First increases their solubility and then there is a decrease with the rise in temperature. First the solubility increases and further the solubility decreases with the rise in temperature. So these kind of substances are anomalous substances and they show anomalous solubility, like globular salt, and the formula is Na2SO4.10H2O. These water molecules, 10H2O water molecules are present here. So look at the graph, page 40, figure 3.8. So see, first there is increase in solubility. This is the solubility in y-axis, z-axis is, x-axis is temperature. So first there is increase in solubility. At a particular temperature, further there is a decrease in the solubility. So this is a anomalous solubility. Sometimes the question is, draw the diagram or name the salt which show anomalous solubility with the help of a graph. So you have to draw this graph where the substance first showing the first increase in solubility and further decrease in the solubility with the rise in the temperature. Actually, there are two processes. In exothermic processes, you know exothermic where the large amount of heat released. Endothermic processes when there is a absorption of heat energy. So in exothermic reaction, the solubility of salt increases with the rise in temperature or increase in temperature, and this is shown by potassium nitrate and sodium nitrate. And solubility increases on lowering the temperature, that is endothermic processes, that is calcium sulfate, calcium hydroxide. So this is you can add in the difference between also you can show here, that is exothermic and endothermic process where the solubility of salt increases with the increase in temperature, and here the solubility of salt increases on lowering the temperature. Pay attention, here the temperature lowered, here the temperature increases.